Now let's look at the ArrayList implementation of the list interface. To define a variable of type ArrayList, you write ArrayList and then in brackets the name of a class, like ArrayList of string, ArrayList of student, ArrayList of point, any class name. So here we say E is a generic type that is to be substituted by a class name. So the ArrayList becomes an array list of elements of class type E, whatever E is. To make use of ArrayList, also don't forget to import the Java util package. You should either write import Java util dot asterisk, or you can also write import Java util ArrayList directly. So when you define an ArrayList variable, actually you get, as we said behind, an array, but this is invisible to you. So for you, it appears like you have only an array list named, in this example, elements, which has no elements in it. And later, for example, you add A, B, C, and D in this order. So if you look at the snapshot on the screen at the moment, we have an array list with the name elements, which has a size of 4, and it has the elements A, B, C, D in it. As I said, you're not aware of this array behind as the programmer, but actually there is such an array to implement it. So the array list provides an auto resizing array, which is capable of holding any type of object, any type either you have created, like student, or a class that comes with the Java compiler itself, like string. The array list maintains some useful benefits of arrays, like easy access and fast random access, because behind still there is this array providing the array list, and it frees us from some tedious operations on arrays. For example, if you were using an array instead of an array list, to be able to insert an element in the middle, as we discussed in the previous section, you would have to shift all elements to the right, all elements after that position to the right, or if you're deleting it, you should shift them to the left. ArrayList does this for you. You don't have to deal with this. It also implements the toString method we discussed in the previous chapters on the array list. So when you use the name of an array list in, for example, the printline method, it will directly print all elements in the array list. For example, here we have an array list of objects where the first element is an integer, the second one is a floating point number, the third and the fourth are strings. So it will just display the results separated, display the elements separated with commas and in square brackets. So we said in the definition of the array list, we write array list, and in brackets we have this generic class name. It's also called a parameterized class, which allows us to define an array list of any class type. We will not go into the details of how you define generic or parameterized classes. That will be discussed in our problem session. So the E in brackets here is, as we said, it's a placeholder for any class type. So for example, you can say array list of string. So altogether, this thing is a type. Then words is the variable name here. So we define words as an array list of string. So array list of string altogether is a type of the variable named words. And as we define it, we also initialize it, saying new type. And here's the constructor. Just like we did before. For example, if we were defining a string, to initialize it, we would say, oops, I'm sorry, just messed up. We would say new string. Similarly, we write here new array list. Now, once you have done this, the methods of words will manipulate this time the elements, where each element is of type string. So let's compare an array list against an array. In the top box, we have the implementation using array, and in the second one, we have the implementation using array list. So if we were using array, we would define, for example, a variable named names as an array of string, and then we say new string of size 5. Later, we can put values into this names array, saying names of 0 becomes Jennifer. Or you can define another variable, say name, which will be initialized by the element with index 0 of the array names. If you want to implement a similar thing in by using array list, this time you say not an array of string, but you say array list of string in brackets. That would be the type again. And the name of our variable is now different. You could just give any names. Here we call it names list. And to initialize it, we say new. Our type is array list string, and we call it constructor, the default constructor with no parameters. If you want to put an element in it, we say names list. Remember, names list here is the name of the variable. Now, this is an object, so we call the method of names list by putting a period at the end and then calling the method named add. So we're calling actually the add method of the names list object, which is of type array list of string. And as the parameter, we are passing the string Jennifer. So the add method of names list will be created. How many elements does names list have in it? None at the moment. So this will be the first one, so it goes to index 0. So this is equivalent to making names list of 0 equal to Jennifer. Note that when you're using array list, writing something like this, saying names list, and then in square brackets 0 becomes the string Jennifer. This is incorrect. You cannot do it this way. You have to go with the add method of the names list. Then to retrieve it, you have to give the index. Again, trying to retrieve the value of names list using square brackets is not again correct. You have to call this time the get method here and provide the parameter as the index. Note that in short, when you use array list, you're not allowed to use the square brackets after the name of the array list variable as we did with the arrays. So when you want to insert elements into an array list, again, here we have the example. This example is actually incomplete in the sense that I have not specified what the type here should be. Actually, I should have written that, like in this case, string, because we're putting in strings. So in other words, take it like we have string here. I'm just trying to have it short. Similar thing also here. So you say just display the list. Well, in the beginning it's empty, so you will not see anything in the output. Just the square brackets. In between the brackets, it's empty. Then you insert tool. So tool would be the first element in the list, so it goes to index 0. By the way, tool, fish, and Pink Floyd, as you know, are group names, rock group names. Then you insert fish. So this is inserted in a separate call to add. Therefore, it's a separate element. It's not part of the same string. So it becomes element index 1 and then insert Pink Floyd. So Pink Floyd as two words together becomes the third element at index 2. Note that after each insertion or addition into the list, we're displaying it by just saying print line the name of the ArrayList variable list, and it will just display it in square brackets, as you can see. Also note that the elements are stored in the order they were entered. This is important. Note that here we did not specify any index while doing the additions. Therefore, they simply get appended. That means they get added to the end of the array list. Let me also erase these marks. So now, if we start removing elements, to remove them, you just say remove. Remember, in the previous slide, what we had in the list was in the order tool, fish, Pink Floyd. Now, if I try to remove the first element, tool will be removed. You also see the initial list here, tool. Here we have U2 in this example, tool, U2, fish, and Pink Floyd. When you say remove 0, element with index 0 is tool, so tool will be removed. Then when you say remove 1, you might be expecting U2 to get removed, but in fact fish gets removed. And the reason for that is as follows. Initially, my list was tool, U2, fish, and Pink Floyd. So these were with the index 0, 1, 2, and 3. When you say remove 0, this item is removed, tool is removed, but note that the moment you remove it, the index gets updated. So at this point, when you say remove 1, U2 does not have the index 1 anymore. It has the index 0. Therefore, what gets removed is the one with index 1, which is fish. That's why here, when you print the final list after 2 removals, you will have U2 and Pink Floyd in the list, not fish and Pink Floyd. You can also search the list for some particular elements. So you just call the method named contains. Remember, the name of our ArrayList variable was list. That's why we have this. This is the name of the variable, the object name. That's list dot you call the contains method, which returns either true or false depending on whether we have it or not. There is a similar method, this time again on lists. This time I call the method index of, and index of gives me the index of the element. Note that contains does not remove the element from the linked list, array list. Similar is true for index of. These two methods do not modify the array list. Contains returns true or false. Index of returns the index, a number, an integer value. And here what we do is we have learned the index of the variable and we placed it into a variable named index. And when in the next statement, when we are calling the get method, as a parameter we pass that value, pass that variable index, so it will return us that element which we know it's fish. In the second if statement, this time we're checking for the string Madonna. If it's in the list, it will say Madonna is in the list. Otherwise, it will say Madonna is not in the list or it's not found. So the ArrayList methods, the most popular ones actually, it's not a complete list, but the most popular ones are the ones we see here. The first one would be add value. This is, as we did before, it's just appending the parameter. Here the name of the parameter is value, so it's appending that parameter to the end of the list. That's important. It goes to the end. Whatever the size of the array list is, it becomes the next element. But it is also possible to call add method by giving a second parameter. Actually, it goes as the first parameter as index. So here we say insert this value at this specific index. So it will place it there. Clear will remove all of the elements at once in a single shot, whereas remove at the bottom, as you can see there, removes a specific element. Here we have remove. It removes a specific element, whereas clear removes all of the elements. Contains, as we have seen, checks if the array list contains such an element. If so, it will return true, otherwise it will return false. Get will return us the element at the index given in the parameter. Index of will find us the value in the parameter in the array list, and if it exists in the array list, it will return the index, which is a value between 0 and size -1, as you know. However, if it's not in the list, it returns -1, which means actually you could also use index of in a way similar to contains and check if its return value is equal to -1 or not. In other words, rather than saying contains, for example, Madonna, you could have said index of Madonna is equal to -1 or not. That's also possible, but if you're checking for the existence of it or not, contains makes more sense. It's straightforward. Last index of returns the index of the last occurrence of that specific element, because in the array list you can have the same element over and over. It could appear several times. For example, you can have two students with the same name and surname in the same class. That's possible. So if such a student name occurs several times, index of gives us the first occurrence, last index of gives us the last occurrence. Now you might ask, how do I get the second occurrence, third occurrence? No, there's no method for that. You will have to check one by one. We already discussed remove index. It will remove the element at this index. And size tells us how many elements we have in the array list. Now, in the array list, one thing, if you want to process all the elements one by one thing you can do is you can go to element index 0, index 1, 2, 3, 4, all the way up to the size of the array, which, remember, we were able to acquire with the last method here. That's an option, but Java provides us another possibility, another tool, what we call the enhanced for loop. This is a different way of writing the for loop. It works on collections, not only on ArrayList, but also on other types of collections also. So you say for in parentheses rather than saying something like I becomes 0, I less than size, I plus plus. Here you say for, you define the loop counter here by giving its type and the loop counter name, and then the collection from which it will get those values. And in the loop body, this variable name, the loop counter, whatever it was, will get values from this collection one by one. In other words, in every iteration of the loop, name will have a different value, each time a different element from the collection. Let's see it with an example. For example, we define sum equal to 0. We're trying to find the sum of the lengths of all strings in an array list. So initially, its sum is equal to 0. We define this time our loop counter with the name s. Our array list is an array list of strings. Therefore, we name it string s, define it as string s, and s will get its values from our variable, array list variable named list. So in every iteration of this loop, s will have another element. So in the first iteration, s will be the element with index 0. Next iteration, it will be element with index 1. Next, it will be element with index 2, whatever, all the way up to the end. You don't need to get the size. This enhanced for loop will end when it reaches the end of the linked list. So when we're done, it will just say total of lengths is equal to sum. Now, you might ask, why do we need this? Why didn't we use a regular for loop starting from 0 and going all the way up to size -1? Yes, you could do it here in this example, but later we will see that there will be cases where we don't have the index. So we will not be able to refer to them with index. This is actually a faster way, and it also enables things that we cannot do in some other cases, as we will see in the future slides. Now, we said when you're defining an array list, the general or parameterized class you use here should be a class name. Now, remember, int, float, char, bool, these are actually primitive types. They're not classes. So that means you cannot create an array list of int. That's not legal because int is not a class name. It's a primitive type. However, Java provides us some wrapper classes. So for int, although int is a primitive type, we have an equivalent wrapper class named integer. Note that since it's a class name, the initial is uppercase. Similarly, for double, we have double with D in uppercase. For char, we have character. And for boolean, we have boolean again with B in uppercase. So you cannot say array list of int. That's not legal. But you can say array list of integer because here integer is a class. Integer is a class which is equivalent to a single integer value. Similar for double, character, and boolean. So, for example, here we define an array list of integer variable with the name list and also initialize it by creating an array list object of integer. We have the similar thing here. So, for example, now we have not an array of integers, but an array list of integers. It was initially empty. I add 13, so it becomes the first element, then 47, then 15, then 9. Then, for example, I want to traverse the whole linked list one by one. So simply I say define a variable named n. What's the type? Well, this is an array list of integer, therefore it should be of type integer. Note that it's an array list of integer class. Here I have defined a primitive type integer n, int n. Note that int and integer are actually equivalent. Java realizes that they are equivalent and it will treat them in a similar manner. So although list is an array of integer class, the elements you get in the enhanced for loop are equivalent to primitive type int. Therefore, you can put them in n. So one by one, it will get 13, 47, 15, and 9 in this order from the linked list. And you add them one by one to sum, so you will get the sum. So this will be your output.